Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be comparing and ordering fractions. To compare and order fractions, it's often necessary to convert the fraction to a decimal. So to do that, we need to understand that we can write fractions as a division problem, because a fraction bar is one way to represent division. So if I have a fraction, the numerator's on top and the denominator's on the bottom, and that simply means you're going to take the numerator, whatever it is, and divide it by the denominator. Now, if you're going to make a long division problem out of it, then you're trying to find out how many times will the denominator go in to the numerator. So for example, if I have 24 over 3, that means the same thing as 24 divided by 3. If I wanted to write it as a long division, I would say, how many times will 3 go in to 24? And of course, that would be 8. If I had the fraction 1 over 8, that's the same thing as 1 divided by 8. Or how many times will 8 go into 1? Now, when we convert fractions to decimals, we can use long division. So if I wanted to convert 1/4 to a decimal using division, 1/4 is the same thing as 1 divided by 4. As a long division problem, we're simply saying how many times will 4 go into 1. Now, 4 will not easily go into 1 unless we add a decimal and some zeros. So I'm going to put how many times will 4 will go into 1.00. So now I'm asking how many times will 4 go into 10? Well, 4 will go into 10 2 times. Then 2 times 4 is 8. 10 minus 8 is 2. Bring down this 0. And then 4 will go into 20 5 times. So 1/4 is equivalent to the decimal 0.25. And that's how we can use long division to convert a fraction to a decimal. All right, now let's look at example 1. It says use division to simplify each fraction below and then plot on the number line. So when we're plotting numbers on the number line, it's a lot easier to plot decimals than it is to plot fractions. So what I like to do is simplify my fractions into decimals or sometimes even whole numbers. So for example, point P is the fraction 15 over 3, which is the same thing as 15 divided by 3. Well, 15 divided by 3 is simply positive 5. So I'm going to put point P right here at positive 5. All right. Q, we have negative 7 over 2. Now, 7 will not divide by 2 evenly. So what I'm going to do is I'm going to use long division to turn this into a decimal. Now, when you're using long division, just ignore the negative for right now. 7 divided by 2 is the same thing as 7 divided by 2. So I'm asking how many times will 2 go into 7? So 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Now 2 will not go into 1, so I'm going to add a 0 here and drop it down. And 2 will go into 10 5 times. And then don't forget the decimal right there. Now, here is the time that you're going to think about this negative. So I'm going to put the negative on there. So negative 7 over 2 is the same thing as negative 3.5. So when I plot that, I'm going to go to the negative 3, and then halfway in between the negative 3 and the negative 4 would be point Q, negative 7 over 2. All right, 9 over 4 is the same thing as 9 divided by 4. So using long division, I want to know how many times will 4 go into 9. So 4 will go into 9 2 times. 2 times 4 is 8. 9 minus 8 is 1. Bring down the 0. Put a decimal point here. 4 will go into 10 2 times. 2 times 4 is 8. Subtract. Add another 0 here so I can bring down. 4 will go into 25 times. And 5 times 4 is 20. So that gives me a remainder of 0. So 9 over 4 is equivalent to 2.25. So here's 2, here's 3. This would be 2.5. So 2.25 would be in between the 2 and the 2.5. So there's point R. All right, and our last problem is negative 20 over 4. So this is equivalent to 20 divided by 4, and that would be negative 5. So I'm going to plot point S down here at negative 5. So this is how we can use division to plot fractions on the number line. Just turn them into decimals. All right, example 2. 4 points are labeled on the number line. Which point represents 1/3? So when I'm looking at my number line, I notice on the far left we have 0, and on the far right we have 0.5. So think of the 0.5 is 50 cents, or 0.50, 50 cents, all right? So halfway right here would have to be 0.25 or 25 cents. So I know if I can convert the 1/3 into a decimal, that would help me know where to place it. So 1/3, what would it be as a decimal? So I want to know how many times will 3 go into 1. So I'm going to have to add a couple zeros here. So 3 won't go into 1, but 3 will go into 10 3 times. So 3 times 3 is 9. Subtract, and that gives me 1. Bring down. 3 goes into 10 3 times. 3 times 3 is 9. I'll add another 0. Bring down. Do you see what's happening here? 3 goes into 10. This pattern is going to repeat over and over and over. So 1/3 is equivalent, well, I'm going to put approximately too because we're going to round this, 0.333 repeating. So I'm going to put a little repeating bar. So it goes on forever. So I know that my answer has to be either M or N, because this answer and this answer are both smaller than 0.25. We want the one that is bigger than 0.25, 0.3333. So I'm going to have to figure out, what are all these marks going by? So from 0 to 25, I have 1, 2, 3, 4, 5 tick marks. So they must be going by 5s. So 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.35. So I'm going to stop right there, because 0.333 would have to be bigger than 0.30 and smaller than 0.35. So we know it would be point M. This point here would represent the fraction 1/3. All right, example 3. Plot the 4 points on the number line below. And on our number line here, we have on the far left 48, and the far right we have 49. So we need to see what these tick marks represent. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means they're going by tenths. So let me erase that. I want to label these. This would be 48.1, 48.2, 48.3, 48.4, 48.5, 48.6, 48.7, 48.8, 48.9. All right, now that I have my number line labeled, I want to take these fractions and turn them into decimals. So for point A, I have 48 and 2/5. So I know it's going to be 48 point something. So I want to know how many times will 5 go into 2. So let me put a decimal there. So I know 5 will go into 20 4 times. So 4 times 5 is 20. That gives me a remainder of 0. So therefore, 2/5 is equivalent to 0.4. So 48.4 would land right there, and I'll label it with point A. All right, our next fraction is 48 3/5. So this time I want to know how many times will 5 go into 3. So let me add a decimal. So 5 goes into 30 6 times. 6 times 5 is 30. Subtract the 30 and I get 0. So 48 3/5 is the same thing as 48.6. So point B could be plotted right there. All right, our next fraction, 48 1/2. Well, hopefully you remember that 1/2 is the same thing as 0.5. So hopefully you can do that without division. So 48.5, this would be point C. And then 48 1/4 be 48 point something. So we want to know how many times will 4 go into 1. So 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. Bring down the 0. 4 goes into 20 5 times. So 48 1/4 is equivalent to 48.25. Now, when you plot the 48.25, notice it's bigger than 48.2, but smaller than 48.3. So it would have to go in between those two. So that's point D. All right, now we've been using decimals to compare fractions on a number line and to plot them on the number line. There's another way we can put fractions in order, and that's to get like denominators. So on this second part, we're going to be comparing fractions and placing them in order by using a common denominator. So to do this, you want to first find the least common denominator. Okay. So for example, if you had 1/2 and 2/3, both of those numbers go into 12. So you could use 12 as your common denominator. But there's a smaller common denominator that you can use, and that is 6, because they both go into 6. So that's when it says find the least common denominator. The reason we do that is because it'll give you smaller numbers to work with. All right. After you find the least common denominator, you're going to rename each fraction using the LCD. And then you can compare or order the fractions by looking at the numerators. So these steps will make a lot more sense once you see it in action. So example 4, use greater than, less than, or equal to compare the fractions below. So we're comparing, in problem A, we're comparing 2/7 to 7/21. Now, when I'm finding the LCD, I look at the two denominators, and I want to look at the larger one first, 21, and I ask myself, will 7 go into 21? If the answer is yes, that's your LCD. So the LCD here is 21. So I'm going to rewrite this first fraction with a denominator of 21. The second fraction I'll leave exactly as it is because it already has a denominator of 21. All right, so let's rewrite 2/7. 7 will go into 21 3 times. So I'm going to simply multiply the numerator by 3. So 2 times 3 is 6. Now that you've rewritten them both with the same denominator, just look at the numerators. 6 is smaller than 7. Therefore, 2/7 is less than 7/21. All right, in our next problem, we have 11/3, and we want to compare it to 17 over 6. So again, I always start by looking at the largest denominator and ask myself, will 3 go into 6? If the answer is yes, that's your LCD. So my LCD here is 6. So the second fraction I do not need to rewrite, but the first fraction, 3 will go into 6 2 times. So I want to multiply the numerator by 2. So 11 times 2 gives me 22. Now to compare them, simply look at the numerators. 22 is bigger than 17, which means 11 thirds is greater than 17/6. All right. In our part C, we're comparing 1/3 to 2/5. So I look at my largest denominator, which is 5, and I ask myself, will 3 go into 5 evenly? And the answer is no. So if they won't go into the other one evenly, then I just multiply them together. 3 times 5 gives me 15. So I'm going to use 15 as my common denominator. All right, so let's start with the first fraction, 1/3. 3 goes into 15 5 times, so I must multiply this first numerator by 5. So 1 times 5 is 5. My second denominator, 5, will go into 15 3 times, so I must multiply this numerator by 3. So 2 times 3 is 6. Now that you've got a common denominator, just look at the numerators. 5 is less than 6, which means 1/3 is less than 2/5. 1/3 is less than 2/5. All right, example 5. Order the following fractions from greatest to least. So I have 7/16, 1/2, 3/8, and 15 over 32. So the first thing I do is I look at the largest denominator, which is 32, and I ask myself, will all of the other fractions go into 32? Excuse me, will all the other denominators go into 32? So 16 will go into 32, 2 will go into 32, and 8 will go into 32. So my LCD here is 32. All right, so I'm going to rewrite each fraction with the denominator of 32. So 16 will go into 32 2 times. So I'll multiply that numerator, 7, by 2 to get 14. 2 will go into 32 16 times. So 1 times 16 is 16. 8 will go into 32 4 times. So 3 times 4 is 12. And then 32, this one already had a denominator of 32, so I don't need to rewrite it. Now, to find the greatest one, all you need to do is look at the numerators. So our largest numerator was 16, and that corresponded to the fraction 1/2. Our next largest numerator was 15, and that corresponded to 15 over 32. Our next largest denominator was 14, and that corresponded to the fraction 7/16. And then our smallest denominator was 12, and that corresponded to the fraction 3/8. So now we have them in order from greatest to least. All right, example 6. Order the following rational numbers from least to greatest. Now, this time, you're going to get a common denominator for all of these fractions, and I'd like you to pause your video and try this problem on your own. When you're done trying it on your own, press play, come back and check your answer. All right, welcome back. I used a denominator of 16 for all these fractions. So on the first one, I said 2 goes into 16 8 times. So this is 9 and 8/16. The second fraction, I didn't need to do anything to, 9 and 3/16. The third fraction, 8 goes into 16 2 times. So this was 9 and 2/16. On my last one, 4 goes into 16 4 times, and 3 times 4 is 12. So this was 9 and 12/16. Now I want the smallest numerator to go first. So that was 9 and 2/16, and that corresponded to 9 and 1/8. My second largest numerator was 3, and that corresponded to 9 and 3/16. My next numerator was 9 and 8/16, which corresponded to 9 and 1/2. And my largest numerator was 12, and that corresponded to 9 and 3/4. And that concludes today's lesson, comparing and ordering fractions.